Hello, we're going to be going over the bridge drop data and how to calculate it today. So if you did this in class, that you should have this table filled in either on paper or somewhere else. So what I do want to point out is that the numbers that I'm using are made up. So the height of the bridge and the height and the distance is the actual ones we used in class, but the numbers that are highlighted in the time slot, I made those up. So those are not the actual data numbers you should use. The only people that should be using this and that are allowed to use those numbers are ones that were not in class and are working from home. So the people that are fully remote learning, you can complete this assignment by using everything I have on the table right now. So if that is you, pause this video now and copy down that information into the Word document that is attached to that assignment. Once you do that, you can come back here and continue this video from this point, and I'll teach you how to fill in the rest of the chart. All right, so moving on. If you were in class, you should have different numbers in this time slot here. So if you have different numbers in there, that's what you should have. This is to show you the necessary steps to take to calculate the velocity, kinetic energy, and potential energy here. So for the velocity, that's what comes first. So velocity is also called speed. So speed or velocity is used to calculate the kinetic energy. But first, we have to calculate it. And we do that using this distance over time here. So if you think about it, it's a really simple formula because it's the distance an object went and the time that it took to go that distance. For example, if you think about running 100 meters, if you run 100 meters in 10 seconds and the person you're racing against runs it in 12 seconds, you ran it the same distance in a shorter amount of time. So that means you won. So that's how speed works. So we are going to take this formula here, and we're going to do distance divided by time for each one of these all the way down. So to do that, you take the distance, and that goes on top, and the time, and that goes in your denominator. Now, something I've noticed that students do is they just punch it straight away in. They do this first, then they put that in. That's incorrect. Make sure you're putting it in with the denominator on top, the numerator on top, and the denominator on the bottom. So 7.32 is the height of the bridge in meters. If you are doing this problem and you got this measurement in class, the measurement we got in class was 200 and some odd inches. Do not do this problem with inches. This is a metric problem. You have to convert that to meters. So it's as simple as typing it in on Google, how many inches are in a meter, or just ask, hey, Google, how many meters is 285 inches? And it'll tell you straight out. So you make sure you're using this 7.32 number. All right, so then if you plug those in correctly, it should be 7.32. Excuse the sloppiness of my handwriting. I'm trying to do this on a touch screen. Divided by the time, which is 1.40. And that's in seconds. Okay, so I'm asking you to put that into a calculator. Okay, so then what you should get, let me type mine in real quick, is 5.23. This number is your speed, is your velocity. It goes in here. So I'm going to take this back. I'm going to do some erasing. So then in this box, oops. All right, so there's the first one. So one more time, if I were to do this formula, I got the time is, this is time and this is distance. So it'd be 7.32 divided by 1.44. Put that into your calculator. You should get 5.08. And then that goes here. So you're going to do that the whole way down. The distance divided by the time. The distance divided by the time. And that will fill out all of these. You need to have those done in order to do the kinetic energy. If you don't do these velocities, then kinetic energy will not be possible. Okay, so like I mentioned, I'm not going to be doing the entire assignment for you. I'm merely showing you how to do each step. Okay, so I'm going to continue doing this through the golf ball and using the golf ball and the tennis ball to kind of show you examples. You should be mimicking every step that I do with your data and your numbers for the soccer ball, baseball, tennis ball, golf ball, bowling ball, all the stuff so that the whole table is filled in. This is meant to help you practice calculating kinetic energy and potential energy. So speaking of kinetic energy, I have the formula right here. So the kinetic energy is equal to 1/2 the mass times velocity squared. So you have the velocity here, and you have the mass here. So that's what you're going to plug into your formula. Oh, that's wrong. The mass is here. My bad. So you're going to do, so 1/2 on a calculator is 0.5 times 0.046 times, and then you put in your speed, and make sure it's squared. And make sure you're only squaring your speed. Do not type this straight into your calculator. It will square the wrong thing. All right. So if you take 0.25 times 0.46, you'll get 0.023 times. And then in your calculator, if you do 5.23 times 5.23, you'll get 27.35. That's where I got that number at, 27.35. And then when you multiply those two together, you should get 0.63. Now this is your kinetic energy. All right, so then this number goes here. So I'll put that in there, 0.63. All right. Now we'll do it for the tennis ball one more time, just so you get the hang of it. So again, for the tennis ball, I'm going to be using, oops, wrong one. The tennis ball's velocity is there. and the tennis ball's mass, which is there. And you simply plug in the same formula, but you just use different numbers. So 0.057. Oops, I had that backwards. So it's 1/2. So 0.5 times 0.057. So this is 1/2 the mass times the velocity, which is 5.08. Squared. Remember, only square the velocity. So again, I like to break it down in my calculator so I don't screw it up, because sometimes if you plug this in order, it will do the wrong form of calculations. So I just take 0.5 times 0.057. That will give me 0.0285 times 5.08 squared. Gives me 25.80. So then you multiply those two together. And that should give you 0.735. And that goes in here. I'm going to round up to 7.4. Okay, so this is how you do kinetic energy. Step 1, 1/2 the mass times the mass. So 1/2 times the mass times the velocity squared, which is right here. So the velocity comes from whatever is in this box on the way down. All right, so now to move on to potential energy. This one's a lot easier because the steps are more straightforward. You don't have to worry about plugging it in the wrong order, because the order is pretty simple. Use green. So for potential energy, all right, the formula is right here. All right, you don't have to calculate anything first, so you could do this straight away if you wanted to. You have the mass times gravity. All right, and remember, gravity is 9.8 meters per second squared, and I put that down here for you so you don't forget about it, times the height. Now, the height is going to be the same thing as the distance, because that was the height of the bridge that we jumped off, or we threw the ball off of. So next, we multiply these all together. So mass times gravity times height. So we have the mass of the ball, which is 0.046 times gravity, which is 9.8, times the height, which is 7.32. Again, please excuse my handwriting on here. It's hard to do on a touch screen. So 0.046 times 9.8 times 7.32. So the potential energy I calculated would be, I'm going to round up to 3.3. All right, and that goes here. So one thing you should notice is that the gravity and the height will not change in these experiments. So the gravity and the height will not change in what you're doing here, because the gravity and the height stayed the same the entire time. because we're dropping it from the same distance, so the height should be the same every time. All right, so let's try this other one for one more example. So then it would be, we do the mass of the tennis ball times the gravity times the height of the bridge. So 0.0 times 9.8 times 7.32. Plug that into your calculator. That gives me 4.08. And that goes here. And then you just continue all these calculations all the way down here. So it should be pretty straightforward as far as that. I think the hardest part is going to be this kinetic energy and velocity calculations. But just go slow, go step by step, break down the math problems so that they're short, and then you should be all good. So when you're done with this, make sure you submit it on Schoology. I should not get any paper copies turned in. And remember, you can only use the data that I have on here if you are not in class. If you're in class, you should have a whole different set of times, and you should use those numbers, not these numbers. Okay? So if you have any questions, reach out to me, and I can help you with these calculations, but they are pretty straightforward. For sure, I would start with the potential energies first because those are really quick and easy to calculate to move on through. All right, so hopefully this goes well, and I look forward to you guys turning these in.